Okay, we are back again. We're going to go ahead and do a saltwater circuit. This is a little complicated, so I need you to really pay attention and not get frustrated because it can be done. So I just want to point that out to you. First thing we're going to do is let's talk about the engineering design process. The overall goal of this is going to be to create light or illuminate the bulb using a saltwater circuit. So it's going to be some trial and error because you want to make sure that in this scenario that we're going to be using to create the moon outpost, you're going to need to create a lighting source. And so there's going to be some salt water left over from some other materials as we're on our outpost. So in this case, you're going to use some of that that output or that leftover water before we reprocess it for something else, we're going to use it to create some electricity. So this is the engineering design process, and as you can see on the screen, the ultimate goal is what we're striving for. You're going to go ahead and ask, well, what am I doing? Then you plan or imagine what could be done to do this. Then make a plan, and then create a prototype, and the prototype is going to be the model or something that you can use to test. And if it doesn't work, then we improve, and it's something that you don't need to be upset about. It's just that we continue to improve and we just keep going through this process, and that's why we call it a process. So let's go ahead and get into what we're going to be doing. Again, as review, a circuit is just a complete path around which electricity can flow. It has to include a source, a power source such as a battery. The materials that are going to that the electrical current passes through are called conductors, and they're going to be connected to the positive and negative ends of the battery in this case, so it's going to create a circuit. That word circuit, just so you are aware, comes from the Latin word circuitous, which just means to go around. So think about the word circle, think about the word circuit, and then look at that Latin word circuitous, and they're all blended together. Okay, so let's go ahead and get started. So where do we see electrical currents or circuits in the world? When you turn the light on and off in a room, when the light comes on, the circuit is closed. When the light is off, the circuit is open. So think for a second about other examples of circuits, and the teacher can pause the video so that way you can have a conversation. Okay, let's go back to this now. So can we actually see electricity? The movement of electricity itself cannot be seen, but the item that is being powered by the electricity can be seen, such as a light bulb. So you can't physically see that electrical current moving through the wires, but you can see the output in this case, which will be the bulb. And that's what we're going to do. So what we're going to do now is let's actually make a human circuit. The materials for this is everybody's going to need to stand up. So the materials are going to be the teacher's going to be the battery, and then you guys are going to be the circuit, the conductors. So we're going to make a circle, and that circle, of course, is representing a circuit. All batteries have a positive end, which is going to be represented by the teacher's left hand, and a negative end, which is going to be represented by the teacher's right hand. So right now, go ahead and create a closed circuit. And this video may need to be paused in order to do that. When you're done, then create an open circuit, just to make sure that we have that visual understanding of what circuits look like. Okay, we're going to go ahead and move on because now we actually have to create our saltwater circuit. So what you see on the screen right now is we have a lot of stuff listed. And the teacher has everything laid out for you. The plastic spoons are just something so you can measure the device. We are not going to use the multimeter, so I apologize if that's appearing on the list, but we're not going to use the multimeter. We're going to keep this as simple as possible just for the idea that we need to learn how to make this design. So everything's going to be laid out for you. And then I have the instructions on the screen so that way they can come back up for you, and the teacher can pause them during each part of the build. And as you can see, we're going to test the electrical circuit by touching the two electrodes together. Once that completes the circuit, the electricity is going to flow from one end or one terminal of the battery to the other, and the terminals are just simply those like the bump on a battery at the top and the flat part at the bottom, or on the 9-volt battery they look slightly different, and on the side of the battery you should be able to see the positive and the negative sign. Okay, and then what we're going to do is we're going to create that saltwater circuit. So using the circuits cards that are being given to you, you're going to prepare your saltwater mixture. Everybody's going to start off with 300 milliliters of water, and then you might want to do 3 separate cups, A, B, and C. Prepare your salt mixture, your saltwater mixture for A, prepare a saltwater mixture for B, and prepare a saltwater mixture for C. This matches the mixtures that are listed on the cards. And again, you may need to pause this as you're going. Then what you end up doing is, in order to collect your data, you're going to insert both electrodes into one saltwater solution. Don't let the electrodes touch, because that itself, because they're both conductors, they're going to automatically light that bulb. But what you need to do is just touch the electrodes into the saltwater solution, and then observe how bright the light bulb becomes and record the current reading from the multimeter. And in this case, we're not going to use a multimeter, so just go ahead and make a visual observation. Record your observation. So it could be a weak bulb, so it's not very bright. We could call that dim, and then you could call it medium light, and then you could, of course, once it gets to bright light, then you can record those numbers. When you're done, you're going to rank your solutions from the dimmest to the brightest by visual observation. But make sure you're following what's on the card. Don't use pre-existing knowledge. You want to go ahead and actually test this out, because when we design our lunar outpost, we're going to need to make sure that we're providing enough electricity to light up bulbs in the living quarters. And then our reflection. Respond to the questions on the saltwater circuit reflection sheet as a group. And then think about ways that you would be able to use saltwater circuits as energy. You're going to need this information later in the week as we prepare to do our outpost. Good luck building your saltwater circuit, and look at the next video, because I have created one to show you step by step what you're doing to keep the confusion level to a minimum. Good luck, have fun, and I'll check back in with you later.